Hi, I'm Justin Weiss from IBM Research, and I'll be presenting our work on design principles for generative AI applications. So, as we all know, generative AI is the hot new technology trend right now. And although there's been a lot of really great work that's examined how to design great user experiences for AI products, there hasn't been anything that's really addressed the unique challenges posed by generative AI. One of these challenges is that generative AI has fundamentally changed the way that people interact with computing systems. This viewpoint was elegantly articulated by Jacob Nielsen in a blog post back in June 2023, where he observed that generative AI has introduced a new paradigm of computing, and he called this intent-based outcome specification. So instead of having users issue a series of commands to a computer, they're now able to specify the kind of output they want and leave the how of how that output is produced to the computer. We've never been able to interact with computers this way. So how can we design user experiences that help people effectively specify what they want the computer to produce for them? Another reason why designing generative AI user experiences is hard is because of this concept that we call generative variability. This is the idea that every time you push the generate button, you get something different back. This is actually a core strength of generative AI, which I'll discuss in a little bit, but it's also a huge challenge for users. We've all been taught that user interfaces should behave in a consistent manner. Every time you click a button, it should do the same thing, right? Well, generative variability violates this principle. So how do we design user experiences that convey this idea to our users? And the last challenge of generative AI is that it's a very risky technology. There's a whole bunch of news headlines that show many of the different kinds of risks and user harms from generative AI, and we've even developed a taxonomy of these risks at IBM that you can see on the right. Some of these risks are things we've already known about from existing AI systems, but they've gotten worse because of generative AI models. And many of these risks are new, specifically because of the generative nature of these models. So how do we design safe user experiences for generative AI that help minimize or prevent these kinds of risks from happening? So here's our answer for how to address all of these challenges posed by generative AI. This is our framework for the design of generative AI applications, and it consists of 6 design principles. 3 of these principles, the ones in blue, should be familiar because we've seen them come up before in the design of AI systems. These are things that we already know are important, but what's different is that we have new interpretations of them when viewed through the lens of generative AI. The other 3 principles in yellow are completely new, and they identify some of the unique characteristics of generative AI. Each one of these principles is coupled with a set of 4 specific design strategies that design practitioners can use to implement these principles within their user experiences, and I'll cover each of these in a bit. Okay, now I'll talk a little bit about how we came up with the design principles, but I'm going to keep this very high level, and I recommend looking at our paper for more details. We started our process with a literature review, and we also looked at prominent examples of commercial generative AI applications. And we came up with a set of 7 initial design principles. We previewed these at a workshop at IUI in 2023, as well as with a group of design practitioners within IBM to get some preliminary feedback. We then adopted methodology used by Salima Amershi and her colleagues at Microsoft to evaluate the principles by having people use them to conduct a heuristic evaluation of generative AI products. And we got a lot of feedback on the clarity and applicability of the principles, and we made a lot of improvements to them. Our last step was to field test the principles with multiple product design teams within IBM, and these evaluations gave us confidence that the principles were usable in real-world product design. So that's a summary of how we developed the principles, and now I'll give an overview of each of the 6 design principles and their associated strategies. Our first principle is to design responsibly, and this is something we should be mindful of when designing any product, with or without AI. This principle is all about ensuring that our product solves real user problems and minimizes harm to our users. Given the new risks posed by generative AI, designing responsibly is more important now than ever. So our first recommendation is to use a human-centered approach to make sure you're designing for the user and their actual needs. The worst thing we can do as designers is to incorporate generative AI when it's not actually solving a real user problem. That said, it can be a challenge when there's many different stakeholders involved in your product. So methods that help you identify and resolve value tensions, such as value-sensitive design, can be really helpful. One of the key characteristics of generative AI is the fact that it may behave in ways that are unexpected. We call these emergent behaviors. These can especially crop up in conversational interfaces where there's no limit to what users can ask. As a designer, you can restrict these behaviors by placing the generative functionality behind UI controls, such as how Microsoft's 365 Copilot uses buttons to invoke specific generative tasks. And finally, it's crucial to test and monitor for user harms. Part of this involves identifying the use cases which generative AI will be used for and working with technologists to evaluate the model's risks in those use cases and identify whether there are any ways to mitigate those risks. Another part of this involves developing mechanisms for users to report harms should they happen. Our second principle is to design for mental models. Mental models represent a user's understanding of how a system works and how to use it. So the strategies here focus on ways to help users understand concepts like generative variability and learn how to use the system effectively. DALL-E does these by providing tutorials and examples of what you can do with it, and also by explicitly showing multiple outputs for your prompt. Another aspect that's important is for designers to understand and measure their users' mental models in order to find discrepancies between them and the conceptual model for how the system actually operates. This is what Upal Ehsan refers to as seams in AI systems. A whole host of usability problems will live within these seams. Finally, it's also possible to have the AI system adapt its responses to your users by teaching it something about them. ChatGPT recently launched a feature called Custom Instructions, which is kind of like a user profile that ChatGPT uses to adapt its responses to the user. Trust and reliance are extremely important issues in any AI system, and we recommend a few ways design can be used to help users calibrate their trust. The first is simply to make it clear what your application can and cannot do by explaining its capabilities and limitations, which is what Google Bard did when it was first released. It's also really important to provide rationales for the outputs produced by a generative model. One way to do this is to show users the model's chain of thought. But for use cases like Q&A, showing source attributions is really important to help people understand where information came from. This is what Bing Chat does. It cites its sources. Over-reliance is a huge issue with AI systems, and one strategy that can help is to add friction to the user experience. Now, this strategy should be used with caution, since friction is generally bad for user experiences. But what we've found in other work we've done at IBM is that sometimes it is important to slow users down at key decision-making points and force them to scrutinize generated outputs. One way to do this is by inserting a copy-paste barrier in between a user and generated content, such as generated source code in this example. And finally, it's really important to signify the role of the AI and how it fits into the user's workflow, because that sets their expectations for how they will interact with it, and it also impacts how much they will trust it. GitHub and Microsoft both position their assistants as a co-pilot, signaling that the user will always remain in control. Alright, now let's talk about the principles that are unique to generative AI. And recall that I said earlier how generative variability is a core strength of generative AI. These strategies are all about helping users leverage and manage generative variability. So first, generative models are capable of producing many different outputs for any single given input. Designers can lean into this characteristic, either by generating multiple outputs and showing them to users, or by generating multiple outputs but only showing the best one to users, however that's determined. Google Gemini does this by showing users a single response to their question, but allowing them to view alternate drafts of other responses that were generated. And once we have the model generating multiple outputs, it becomes important to visualize the user's journey. Show them the history of everything they've generated, like how DALL-E shows a user's history as a gallery. But it's also important to include the user's prompts and model parameters in this history, since they may not be able to easily reproduce their results otherwise. Users will also need some way to manage all of the outputs they've generated, so features like DALL-E's collections that help them curate, annotate, organize, label, search, and filter can really help. And finally, in some use cases like source code translation, the multiple outputs produced by a generative model may all look the same. This is a prototype interface we developed a few years ago that helps software developers see the subtle differences that existed across a large set of mostly similar code translations produced by a generative model. Co-creation is the idea that both the AI and the user are able to make modifications to the same artifact. And this is a style of interaction that works really well with generative AI. Since some portion of the co-creative process will involve users writing a natural language prompt, it's really important to help users craft prompts that are effective for their task. IBM's watsonx.ai does this by providing a library of examples that are known to work well. It's also important to provide users with controls over the generative process itself, and these can include generic controls like temperature or random seed or the number of outputs, which are independent of the specific underlying generative technology. And these are a few examples from Dream Studio. But designers might also be able to provide controls that are specific to the use case or the technology. For example, IBM's Cogmol is a system that generates molecules, and it provides users with controls over specific molecular characteristics like water solubility. And finally, co-editing is a key enabler of co-creativity. Both the human user and the AI ought to be able to make modifications to the same artifact. The way Adobe integrated generative capabilities into the same design surface as the existing image editing tools in Photoshop is a good example of this. Our last principle is design for imperfection. And as we all know, generative models don't always produce perfect outputs. Sometimes these imperfections can be objective, like a hallucination in a Q&A use case or a bug in generated source code. But they can also be subjective, like an image you don't like or that didn't quite fit your prompt. It's really important that users understand that there may be flaws or uncertainties in generated output. If you're able, you can make them visible by explicitly highlighting them, such as this prototype we developed a few years ago for showing uncertainties in a source code translation. You may also be able to use domain-specific metrics to evaluate the quality of the generated artifacts and help the user understand if they meet their requirements. This is an example from the IBM COVID-19 Molecule Explorer that shows various properties of generated molecules. Another way to cope with imperfection is to offer ways to improve the quality of an artifact, such as how Google Gemini lets users modify its responses to be longer or shorter, more casual or more professional. And finally, feedback mechanisms can be used to flag outputs that don't satisfy users' needs, like how ChatGPT lets users provide thumbs up, thumbs down ratings. This feedback can be really useful for collecting data that can be used to tune the underlying model. So in this talk, I've given a whirlwind overview of why we need design principles for generative AI applications, how we developed our design principles, and the strategies designers can use to implement each of these principles within their user experiences. Our paper goes into much more detail on a few topics I haven't been able to cover here: our development and validation process, more detail on the principles and strategies themselves, as well as different goals that users have when working with a generative AI application. We also talk about how we got our principles adopted by multiple product design teams within IBM, which is always one of the challenges when developing design principles, getting people to use them. So on that note, I hope this talk has been informative, I hope it motivates you to read our paper, and I hope you find our principles useful for designing excellent user experiences with generative AI applications. Thank you.